Hello everyone. Today our topic is about electric charge. In the previous lesson also we talked about electric charge. Also we explained in the previous lesson how objects will get charge or how object it can gain charge or how it will be charged. So also today we will talk about electric charge and also or exactly about attraction of uncharged objects. As we mentioned in the previous lesson, when you will have two objects, okay, they two different charged objects, okay, they will attract each other. But today we will see we will have attraction, but this time it's between one object is charged and the other one it is uncharged. So example, we will take an example. A charged object will attract any uncharged object close to it. For example, the charged screen of a TV will attract dust. Usually whenever you will look at the TV or you will touch the TV, you will see there is a dust on it. How or why this dust it's on the TV? This is because of the screen TV. It is what it's charged. It has charge, and the dust it's uncharged. So we will see how this it will happen. If you will take a look on this diagram, you will see here what do we have? Here we have two objects, okay? The first one, this one, it's charged. As you can see here, there is only positive charge. That means this object is positively charged. While this object, which is aluminium foil, it's uncharged, okay? Because as you can see, the number of here we have a negative charge and positive charge, okay? So what will happen if you will bring this object close to the aluminium foil, you will see it will attract it, okay? Why it will attract it? The explanation is here it's positive and here it's mixed, positive and negative. So now what will happen? This positive charge, okay, it will attract all the negative, it will be attracted to the all negative charge on this aluminium foil, okay? So this is what do you mean by that? Charged objects, it will attract uncharged object, okay? Then earthing. Earthing, what do you mean by earthing? It means connecting something to earth. Earthing, if enough charge builds up on something, electrons may be pulled through the air and cause sparks. What do you mean by this? Okay. Of course, maybe most of you saw or when you go to gas station or petrol station, they say turn off your car, okay, turn the engine off. Okay, what do you think? Why they are saying like this? Okay, the reason behind this, it's what? When the car is on, so what will happen here? There's electricity, it's passing through the car. So maybe the charge of the electricity, it will build up on the car, and then what will happen? It will make a spark. If it will make a spark and there is petrol, so what will happen? So the petrol, it will burn. So always they say turn off your engine before you put fuel to your car, because when you will turn it off, that means now there is no electricity passing through the wires of the car, and the chance or the possibility of building more charge, it will be less. The same thing it happened with lightning. Lightning, it's what? It's clouds. These clouds, it has charge, and when this charge, it will build up, it will reach a point then what will happen? It will make the lightning. This, it could be very dangerous. So to solve this problem, people, what they do, they for example, they put a wire, okay, from the object, and they connected it to the earth. So in this case, what will happen? If there will be any charge trying to build up in this object, because it's connected now to the earth, so what will happen? All of these charges will goes to the earth, and it's like one of the ways for safety. So to prevent charge building up, objects can be earthed. What does that mean? They can be connected to the ground by a conducting material so that the unwanted charge floats away. The second kind of charge, we call it induced charges. Induced charges, it means making an object charged without touching it. How's that? Here, in this example and the previous lesson, when we were talking about rubbing objects together, okay, when you rub objects together, they will get charged. But here, what we will do, we will make an object charged without touching it. How is that? Without rubbing it. Take a look on this one. You have charged rod. It has positive charge, so it's positively charged. And you have an object. This object, it's neutral. It has no charge. Why? Because number of electrons, it's equal to the number of protons. When you will bring this rod close to this one, what will happen? Here, this charge, okay, it has electric or we call it magnetic field or electric field, okay. What's that mean? It means this object, it will have effect, it will affect on this object. Now, what will happen? This object will try to be balanced with this one. What's that mean? Now, if we will bring this one close to here, at the end, what we will get? Number of positive charge here, it will attract equal number of electrons here. Now, if you will count this one, it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, what do we have here? Here, these two, now they are equal. Because they are equal, now, what is the charge here? There is no charge. It's neutral. But if you look at the other side, what happened? Now, this object, it's positively charged. Okay? But this charge, it's what? It's temporarily. What's that mean? It will last for a short time. It will last when the charged object, it's close to the uncharged one. Okay? Induced charge, it means making charge that appear on an uncharged object because of a charged object nearby. Okay? It's like forcing an object to be charged. This is what they mean by induced charges. Unit of charge. The standard international unit or the SI unit of charge is the coulomb. Coulomb, or a shortcut for it, it's C. How much it is this or how much is the value of coulomb? It is equal to the charge on about 6 million electrons. Okay, so it's like when you will say 1 coulomb, it means you mean 6 million electrons. Although it is not defined in this way, so one coulomb is relatively large quantity of charge. So what do? They use another unit they call it micro coulombs. As we know that micro, it's equal to 1 million of coulomb. So 1 microcoulomb, it's equal to 10 to the power of minus 6 coulombs. Okay, it means 1 over 1 million. The example, it's like why they use microcoulombs here. The charge on a rapid polythene rod, its rod is typically only about 0.005 micro coulomb. Okay, it's like why they are not using coulomb, because this is like a large unit, a big unit. So what do? They deal with micro coulombs. Although they deal with micro coulombs, it's still like here we have this example, a polythene rod, the charged polythene rod, the amount of charge in it, it's how much? It's about 0.005 micro coulomb. Using electrostatic charge. Here we have some of the uses of electrostatic charge. For example, the first example, it's electrostatic precipitators. From its name, it means making precipitant, making things to precipitate or settle down by the help of electrostatic. Electrostatic precipitators are fitted to the chimneys of some of the power stations and factories. How it works? If you look at this diagram, here this is a chimney. Here waste gas and ash. So here you will have a factory, and factory will produce this gas and ash. When this gas and ash, if this gas and ash will, especially the ash, will goes to the atmosphere, it could be harmful. Okay, so it will affect on all the living things. So how to solve this problem? What they do, when the ash and gas, it passes through this pipe here, when it moves to this area, what will happen? Inside this chimney, there is what? There are many wires. Okay, as you can see here, these are the wires. Okay, the positive and negative. This wires has positive and negative. Now, when this air or this ash, it pass here, when it will pass through this wires now, or between these wires, what will happen? This ash will be charged. Because it will be charged, so it will be attracted by these wires. And then now, as you can see what it's happening, all of this ash, it's sticking to this, or it's when it attract by the wires, it will stick to it. And if you will compare this air here, or this gas, and here, you will see there is much difference between them. Here it's full of ash, but here it's clean. See, waste gas, which it's cleaned. So this is one of the uses of electrostatic charge. Second example, or second use, is photocopiers. Photocopiers, it's what? It's like printers. Okay, how it works? Here it's the principle of it. How it works? Number one, inside the photocopier, a light sensitive plate is given a negative charge. So here now you have this plate, it has a negative charge. Okay, then an image of the original document is projected onto the plate. Now if you will focus, now firstly all of it was negative charge, but now if you will focus here, see the negative charge they form the letter H. Okay, now what they will do next? Ink, powdered ink. Powdered ink is called toner. Okay, is attracted to the charged areas. And now what happened? All this toner or this powder will be attracted to this area. Now as you can see, they write. Then a blank sheet of paper is pressed against plate and picks up a powdered ink. Now see, at the end the paper is heated so that powdered ink melts and sticks to it. The result is a copy of the original document. This is the principle of printers. Okay, for example, the printer that we have in the school, the one that we use it for copying or printing exam sheets or all the sheets. Okay, the principle of it, it's as you can see, plate with negative, then image of the original document will be placed on it, and now you got the image, then a powder, this ink is as powder, will be attracted to the charged area, then a blank sheet, okay, will be pressed against this one, and at the end you will get a copy. The third uses of electrostatic charge, it's what? Laser printers. The third example of electrostatic uses, which is in laser printers. As you know, we have some printers, we call them laser printers. How it works? It has the same principle of photocopiers, but the exception or the change is what? It's in this stage, in stage number 2. In stage number 2, here an image of the original document is projected onto the plate. In laser printers, what will happen? This stage, who will control it? It's the computer. Okay, a computer controlled laser scans the plate strip by strip to create the required image. Of course, you saw this one, the laser printer. You will see there's like something inside it, how it moves. Okay, it goes backward and forward, and it will print or it will make image or print required image. Questions. These questions today, all of it will be your task. So your task is to solve this question. That was everything for electric charge. I hope everything it was clear. Again, please, when you will finish watching this video, write a comment below. If you have any suggestions about the videos, please don't hesitate to write your suggestion, and don't hesitate to give your opinion about the videos. By the end of this lesson, I hope everything was clear. Stay safe and have a good day.